we can express as, or vector p is going to be its magnitude times its direction, which I'm going to call u hat sub p. So it's going to be a unit vector. For this style of presentation, we're going to assemble this using those cosines. It's going to be different when we get to Wednesday's example, the more common way. We have a different style for assembling it, but it's the same idea. Times its magnitude. So the magnitude we're actually given, p is 100 pounds. So what we need to find is u hat p, this unit vector which describes the direction of p. So looking at the figure, we have p is 60 degrees as measured from the positive x-axis. So to find the I component of the vector, all we have to do is take the cosine of the angle it makes with the positive x-axis, which again is given to us. So that's easy enough. For the j component, we do the same thing, but for the y-axis. So we need the cosine of the angle it makes with the positive y-axis. So what angle does it make with the positive y-axis? How much?
135.
Right, 135. So it makes a 45-degree angle with the negative y-axis, but we always want to take the cosine of what it makes with the positive sense of each axis. So it's going to be not 45, but the supplement to 145, so 135. Right, the signs will work themselves out. The SIGN signs will work themselves out. And then for k, we do the same thing with cosine of the angle it makes with the z-axis. So here we have measured from p to the positive z-axis is a 60-degree angle. We can then put this in decimal form to make it easier to work with, or I should keep it as a fraction. So this is just 1/2 I minus root 2 over 2j plus 1/2 k. There are no units. Despite being called the unit vector, it just means it's unit magnitude, but it's a dimensionless quantity. And we can check to make sure it is indeed a unit vector by finding the magnitude of it and making sure it's 1. So 1/2 squared is a quarter. 1/2 squared is a quarter. Root 2 over 2 squared is going to be 1/2. So we're going to be, if we add those up, we get 1. And we get, indeed it is a unit vector. It has a magnitude of 1. So again, this just describes the direction. We were told the magnitude. So now we can get p in vector form, in component form, by multiplying the magnitude times this direction we just found. So we have a scalar times a vector. So all we do is distribute this scalar component in, and we can get an end result of another vector. So if we do that, we get, this is p, where did I write here? So 50 pound, or 50i minus 70.7j plus 50k pounds. So this is an ideal presentation. It's very straightforward to get our vector into component form. Unfortunately, at least in this class, it's a pretty rare occurrence that it's presented this way, but it is very straightforward to do. Questions on any of the steps here? So we were given its magnitude, found the unit vector in this case, and then got to our vector in component form. So p does have units. That came from the 100 pounds. The unit vector did not have units. So that one's pretty straightforward. A little bit more complicated now. Let's move on to q, because we also have to get those components so we can add them together to get the resultant. So I'm going to draw just isolate q by itself so we can see how this works. All right, so again, q is projected onto this xz plane. So from that plane, it's 30 degrees above the plane to get up to here. And to get to that within that plane, we have to rotate from the x by 40 degrees. Right, so we need to find how much of q is in the y, in the x, and in the z direction. So for this presentation, the method I use, we don't find the unit vector in order to do it. I basically break it into two 2D problems to do, and then assemble the vector from there. There's other methods you could use where you would directly find the unit vector. In this one, you don't. So basically the premise here is we can decompose Q into two triangles. So we can see the triangle that is perpendicular to the XZ plane as one, and then another triangle that is within that XZ plane. So I'm going to start by looking at that vertical triangle, and I'm going to project it onto just this flat board and see what we have there. So if I'm standing here and I'm looking at Q, this is the y-axis, this is the XZ plane, and the hypotenuse is Q itself, and we're given that Q has a magnitude of 60 pounds. And if we're standing on the XZ plane looking at this triangle, this is that 30-degree angle, and it's a right triangle because the y-axis is perpendicular to the XZ plane. So if you're looking at the triangle, this is the amount of Q that's only in the y direction. None of this is in the y direction. This is the amount of Q that I'm going to say is in the XZ plane. So looking at this, it looks just like what we saw for the 2D problems. So I can find what these legs are because I know the hypotenuse and I know this angle here. So QY is just going to be my hypotenuse times sine 30. So that means 30 pounds of this vector are in the y direction. And I can see how much is not, it's not purely in the x, purely in the z, but at least I know, so that is this leg over here. I at least will know how long that leg is. How much of it is at least in the xz plane. It will be 60 cosine 30, or 52 pounds. Okay, so just like what we saw on Wednesday. So I know how much is in the y. I don't yet know how much is only in the x and how much is only in the z. And that's what the components of the vector tell us, is how much are only in these pure axial directions. But what I haven't used yet is this second triangle over here. So again, I'm going to take this and I'm going to project it onto the board. So this view is, imagine we're sitting, if the y-axis is a pole, we're looking straight down, and we're looking at this triangle here. So now we can see how our axes are set up. This will be our positive x-axis. This is our negative x-axis as looking down from a pole. And then we know that this is that 40-degree angle. Now the way that these two things are linked is if you look at this longer dashed line, which we found in the previous step, as a leg of this triangle, that longer dashed line is actually the hypotenuse of this triangle. So this is also QXZ, which we found already to be 52 pounds. And if we look at this triangle, this leg of the triangle is only in the z direction. And this leg of the triangle is purely in the x direction. Because again, it's this leg, and I'm looking at this leg. So from this second triangle, I can now find how much of it, I already know how much is in the xz plane, but now I can refine it further. How much is only x, how much is only z. So qx will be 52 cosine 40 from this second 2D triangle. So qx is going to be 39.8 pounds. And qz will be 52 sine 40. And that'll be 33.4 pounds. treating these just as geometric figures right now, not taking any of the signs into account. So I know at least how much is in y, x, and z at this point. So now I just need to assemble that all so that I can have my vector q. So nowhere here did I find explicit what the unit vector is. I'll come to that in a moment. So what's vector q? I now need to look at these three components I found and just assemble them. So that's the important one. But we have to be careful because now we need to pay attention. Should it be a positive quantity? Should it be a negative quantity? And that's where these axes are going to help us. So from the origin, we went in the positive x direction to get that qx value. And that came from that original picture there. So the qx should be positive, 39.8 in the I hat direction. qy, again from the origin, we're going in the positive y direction to get there. So we're going to add 30 in the j direction. But now if we look at z, in this projection, to get from the origin to q, we had to travel in what we've defined as the negative z direction. So the qz term will be, that's the right magnitude, but it's going to be minus 33.4 k to get there. And this will be in pounds. And like I said, on Tuesday, we can think of a vector as a set of instructions. So what this would tell us to do is if we start at the origin, if we go 39.8 pounds in the x, if we then go, well, I'll go z next, negative 33.4 in the z, and then we go 30 in the y direction, we get to that same point. So I could have either told you those two angle measurements and that one magnitude, or equivalently to get there, I've told you these three directions that are only in the x, the y, and the z direction. All right, so the last step is find the resultant. That's the easy step here, at this point at least. Just like we saw in 2D, we're going to add the like terms together, and here we're going to leave it in component form. So adding the I component of P and the I component of Q, we get 89.8 I minus 40.7 J plus 16.6 K pounds.